Okay, so today we're going to be talking about simplifying radicals, and we've already spoken about them a bit. This is just kind of an official lesson about it. So the deal is that when we're talking about squares, we literally do mean a square. Okay, and so if I say, hey, if the area of this is 25, okay, what would be the length of each side in order for the area to be 25? And you would say, well, it'd be 5 times 5. Okay, and so also, if I said, okay, what if the area of this is, say, 50? What would be the length of each side? And you have to think about, like, what times what would make 50? And so if it's a square, it would have to be x times x is 50. So you could solve it and say x squared is equal to 50. The square root, if you want to get rid of the squaring of something, you square root it. Square root of 50 is not very nice. It's irrational. But you can break it into the square root of 25 times 2 or 5 root 2. Let's check it. What if I take 5 root 2 times 5 root 2? I get 25 root 4. Square root of 4 is 2. When you take 25 square root of 4, that means 25 times the square root of 4, which is 25 times 2, which does give us 50. So if you have a square with both sides being 5 square root of 2, their area would make 50. And so squares and square roots and, those are related to each other. So now that we're in geometry, and after geometry, you will be squaring and square rooting things, but it is related to the area of a square. And so some of the properties we're going to use when we're square rooting would be that if you've got a square root and it's irrational, if there's a perfect square factor who divides into it, like the square root of 4 or 9 or 16 or 25 or 36 and so on and so forth, if one of those perfect square factors into it, then you should simplify it by breaking it into that factor times another number to give you that square root. And then take the square root of the item that you can. And so your answer to the square root of 52, the simplified form would be 2 root 13. Don't say 2 to the 13th, square root of 13th. It is not at all the 2 to the square root of 13. That's not what you're doing. You're timesing 2 times the square root of 13. You can say 2 root 13, 2 times the square root of 13. Those are options, but don't say 2 to the 13th, square root of 13, because we're not powering things. The next example is very similar. If there's a couple of square roots that go into it, 9 would go into it. Go with the biggest one because you want to break it down as far as you can. All right. So moving forward, if you want to multiply radicals together, you may multiply the square roots together. If you multiply numbers, factors times radicals, multiply the number factors together to get 10, multiply the square root factors together to get 21. Here will be your answer to this right here. So I do want you guys to know the properties. How can you multiply these things? Well, how can you divide them? Well, if you have a quotient underneath the radical, you can break it up into the numerator and the denominator, each being their own square roots. And so here's an example of 3/5 being the answer to the square root of 9 over the square root of 25. Here is an example of the square root of 7 over 4 being the answer to the square root of 7 over the square root of 16. One thing is, division is kind of the bane of all mathematicians. There are other things that are irritating, but division's hard. And so if you had to divide like 2.735 by 2, you could put 2 in the box and divide 2 into 2.735 and you would be okay. Okay. However, if you had the reciprocal, 2 over 2.735, imagine 2.735 trying to divide it into 2. That's hard. You got to move the decimal. You got to add some more placeholders. You really, truly have kind of a heart, not very beautiful thing for your heart. Okay. And so the thing is, one rule we've made is because it's so disgusting to divide by a janky decimal, and irrational values are the jankiest of decimals. They don't end and they don't repeat, is how about we say no irrational values can exist in the denominator? We just want to avoid that altogether. So we're going to rationalize the denominator by timesing top and bottom by that offending square root. So if you see a square root in the denominator, you're allowed to multiply top and bottom by that square root, which is just 1, and then you can simplify it. Okay, and so that helps alleviate the issue with, hey, we don't like to divide by janky numbers. Okay, and irrational values are the jankiest of values. So you start with 3/5, you times top and bottom by the square root of 5th, 5, which you can, because that's just 1. The identity property says you can times any number by 1, and it'll change how it looks. It just won't change its value. So times the top by square root of 5, you get 3 square root of 5. Times the bottom by the square root of 5, you get square root of 25, who is 5. And this will be your answer. If the coefficients would reduce, the 3 and the 5, then you should. Okay. The free numbers can reduce. The radical numbers could reduce as well. So here's the rule about radicals. No perfect squares can be left. Okay, if there's a perfect square factor, you got to factor it out and simplify. You can't leave fractions underneath the square root. And last but not least, no square roots can be left in the denominator because nobody wants to divide by a janky decimal. Okay, so let's practice breaking this up. And what you're going to do is look for a perfect square factor who goes into it. Square root of 500 is irrational. We don't like her. And so if there's a perfect square factor who'll break it down, there are several, including 25 and 4. The biggest one that goes into it is 100, though. 100 times 5. And that would be 10 times the square root of 5. Okay, so that would be as far as you go. Square root of 80, there's a couple square root factors who go into it, including 16. 16 times 5. So that'd be 4 root 5. Okay, so that's how you break them up. Look for a perfect square factor. So take the number, divide it by the perfect squares, and see which number goes into it first, the biggest number that goes into it. So this is going to be the square root of 90, pardon me. And that would be 9 and 10, and that would be 3 root 10. Okay, so let's keep trucking. If you're multiplying, remember, like we set up here, you multiply the number factor. So 5 times 1 is 5. Square root of 2 times square root of 2 is square root of 4. Square root of 4 is 2. Remember, 5 square root of 4 means 5 times the square root of 4. And so it'd be 5 times 2, which is 10. So that will be our answer. Okay, let's keep trucking. Okay, here we go, over here. Okay. There's a couple ways to do this. The square root of 20. We can break it up into the square root of 4 and square root of 5. That's going to be 2 root 5. If 4 is on the numerator, that will reduce, but we might as well rationalize while we're here. 4 square root of 5 over 2 times square root of 5 times square root of 5 is square root of 25, which is 5. And so that would be 5 times 2, which is 10. Now we can reduce the coefficients. You get 2 square root of 5 over 5. Just like you can reduce numerical coefficients that are outside the radicals, you can also divide square roots that are underneath the radical. So notice the square root of 6 and square root of 3 are under the radical. You can reduce those or divide them. So you get 8 and then the square root of 2. Square root of x times square root of x, square root of x squared. And squaring and square root are inverses of each other. So to square a square root, what squared makes x squared? Well, x. So the square and the square root undo each other. Next one, to multiply this out, you get 15 square root of 12. Perfect square that goes into 12 is 4 times 3. That would be square root of 4 is 2 times 15. Well, it would be 30 root 3. All right, let's keep going. Excuse me. If you take 3 square root of 2 and you square it, it means you take it by itself again. So you take 3 square root of 2, times 3 square root of 2, you get 9 square root of 4. Square root of 4 is 2, so it'd be 18. Okay? We cannot leave a radical in the denominator, so we can multiply top and bottom by the offending radical. So if we times top and bottom by the square root of 2, let me see if I can make this work, times it by the square root of 2 over the square root of 2, which is just 1. You get the square root of 2 over the square root of 4. The square root of 4 is 2. And if there were coefficients that were reduced, we would do that. Times this by the square root of 3 over the square root of 3, you get 3 square root of 3. And then on the bottom, you get square root of 9, who is 3. And then these coefficients will reduce. You get the square root of 3. Square root of 7 over 16 makes the square root of 7 over the square root of 16. That's the square root of 7 over 4. Okay. Next thing is Pythagorean triples. We talked about this yesterday, and I want to kind of take a couple minutes to look at it. If you have a right triangle with sides 3, 4, and the hypotenuse of 5, that will be a Pythagorean triple. So will all of its factors. What do you mean, woman? We'll take all those sides, and if you times them by 2, that will also be a Pythagorean triple. Okay, so notice if I times this by 2, and this by 2, and this by 2, I get a new right triangle that's a little bigger. This is 10, this is 6, and this is 8. If you do the Pythagorean theorem, it will work. Okay, so any factors, that you multiply by this parent function is going to make a new triangle. So like one of my favorites is to take 3, 4, and 5 and times it by 10. So you have 50 and 30 and 40. Yes, that'll be a Pythagorean triple. So it's kind of cute. And now another thing is 5, 12, and 13. Those are parents. So if you wanted to make something just a little bit bigger, you could double each side. So you get 10, 24, and 26. Another parent is 8, 15, and 17. Again, you can multiply each of those sides by whatever number you want, and it will make a Pythagorean triple as well. Times it by 3, times it by 2, times it by 10. And same with 7, 24, and 25. And so yesterday we did these exact questions to be like, oh, is this a Pythagorean triple? Okay, we also did Ralph's question. So we're just going to do the bottom one to practice this. Okay, if you've got a TV and the bottom is going to be 16x, this is 9x, if the hypotenuse is going to be 42. Okay, let's figure out what x is going to be. Okay, so you do 16x and then squared plus 9x and that's squared is equal to 42 squared. So 16x squared means 16x times 16x. 9x squared means 9x times 9x. And so 16 times 16 is 256x squared. 9 times 9 is 81x squared. And then 42, don't know that off the top of my head. And so we get 1764. If you combine like terms here, you're going to get 337x squared. That equals 1764. Divide both sides by 337. Pardon me as I yawn. There we go. So x squared is equal to a certain number. Let's see what I get here. 1764. 1764 divided by 337. And if I do the square root of it, I got 5.23 about. Okay, 5.23. I'm going to take the square of that whole decimal. Okay, so the square of that whole decimal is going to give me about 2.3. Okay, x is about 2.3. Okay, so if I take x is 2.3 and I put it back in our problem, 16 times 2.3, and also 9 times 2.3, I'm going to get the links to actually be 36.8. And this right here, this will be in inches. And this will be 20.7 inches. Okay, so that's how you do this question. All right, I hope you have a great day. Thank you. Bye.